done lessons on imaginary numbers, complex numbers, quadratics are right behind it. It's just kind of an all the time. If you note, this one doesn't have a CMHW. There's a quiz over this that you'll do in class one day next week when I've covered all the stuff. All right. So you'll hear me a lot this year talk about the fundamental theorem of algebra. So I'm not exactly sure how they decided this would be the fundamental theorem of algebra, but if you do take calculus, there's a fundamental theorem of calculus that pretty much in calculus 1, you do two big things in calculus 1. You do derivatives, like half a semester you work on derivatives, and then you do the inverse of derivatives, which are called antiderivatives or integrals. And so the fundamental theorem of calculus is that they are actually inverses of each other. It like wraps up all of Cal 1 in one nice statement. The fundamental theorem of algebra picks one tiny little piece of algebra and says something about it. So I'm not sure why that's so fundamental, the whole thing. My fundamental theorem of algebra is that algebra is a toolkit for other classes. But anyway, the fundamental theorem of algebra sounds very wordy and mathy, but it boils down to one thing. Here's the official wordy mathy thing. A polynomial of degree n has n solutions. All right, let's put that into English. All right, this means equations that are polynomials, and polynomials will never have x under a radical. They will never have x in the denominator. If they're under the radical, those are radical equations. If they're in the denominator, those are rational equations. If you have a negative exponent, then you could put that under the radical and you'd be back to having a rational equation. If you had a fractional exponent, that could be written as a radical, so it gets back to a radical equation. Polynomials are where x's are just, sitting there, all right? And then you have various powers in them. So it's about the powers. So we're talking about quadratic equations. So my first blank here is quadratic equations. So do you know what makes an equation a quadratic equation?
The x squared.
The x is squared. So the highest exponent is a square. So we would say quadratics are equations of degree 2. And that means we should expect 2 solutions. So if we were doing cubic equations, you would expect 3 solutions. So that's the fundamental theorem of algebra.
This is where you make it equal to 0, and then you get a positive solution and a negative solution?
Sometimes you get 2 positives, but definitely 2 solutions. Or you have potentially 2 solutions. So let me just give you a little pullback from algebra and you can see. So the word solutions, there's like 4 different words that are often used for solutions. But what it means is if you put a graph on an XY axis, the solutions are what you get if you set it equal to 0. So I'm going to give you 4 terms that mean the same thing. Solutions are sometimes called the zeros. Do you remember maybe in Algebra 2 ever having to find the zeros? Okay. Well, the zeros are, I don't know why I started with a curly X when I wanted a little star. The zeros are where your graph hits the x-axis. So a lot of times, quadratics, which make parabolas when you graph them, many times they will hit the x-axis in 2 separate places. Now, I drew it where I have a negative solution and a positive solution. I think what you're thinking about is the plus minus when you square root and it's put pluses and minuses. But sometimes you won't get a positive and negative. If I had scooched this over, it might have hit on both positives or both negatives.
Yeah.
All right. So the reason they're called the zeros is if you have an x-intercept, its y value is 0. So, and that's why we can set the equations equal to 0 because we're like replacing y equals with if y was 0, what would be my x solutions? They are also called the x-intercepts for obvious reasons because it's where your graph intercepts the x-axis. And in some situations, you may hear them referred to as roots.
Yes, I've heard that.
So, anyway, quadratics, you have potentially two solutions. However, what if the vertex was right on the x-axis? Well, it doesn't go below it and come back up, does
We
it?
only have one.
Okay, so it's one unique solution, but if you were factoring and finding it, both factors would have been identical. So sometimes they call this a double root because you actually do get solutions. It's two solutions, they're just both the same solutions. All right?
So for something like that, like say we have a problem and it's like that, do you want both answers or just the one?
Just the one. If I'm asking you for the zeros, which we'll do in lots of polynomials throughout the coming months, if I ask for the zeros, if something's a double root, you just tell me, oh, it hit at one. That the intercept was at one. But you'll see in this section, we'll discover when what's going to happen in the quadratic formula that would make you have two solutions, or what would cause you to only have one unique solution. And then there's the possibility of having no
Isn't that
real
where it doesn't
solution.
touch the x-axis
Yeah,
at all?
so at that point, here I'm going to make one open upside down, so it'd be below. This one has no real solutions because somewhere where you were doing the math, you got underneath the square root and you had a negative under the square root, so it will have imaginary solutions. So, anyway, we will definitely discuss that a little bit more. But this is just kind of pulling from things you already know to go, oh yeah, I already know a lot about this. You already do know a lot about this. Okay, we are going to do 4 different methods for solving quadratics. This first method is called the zero factor method, and that is my go-to method. Anytime I'm solving a quadratic, I'm going to check and see if I can factor it, okay? But this is only if the instructions say specifically use the zero factor method, then I can promise you it factors. Occasionally when you factor, things don't factor. There's no pretty factors. And the quadratic is prime. So you may have seen that. I think there's a prime that's going to show up on your test, and it's on that little 8 problem review thing. I think there's a prime. Because you try all the combinations, and there just simply is not a combination. Well, that doesn't mean it can't be solved. It means you have to go to using the quadratic formula because you're going to not get pretty numbers that can be written. You're going to get not numbers that can be rational. You won't get a solution that can be written as a fraction or a nice integer. You're going to get some square root nasty garbage on your answer, which could actually graph, but it's some funky place between grid lines. Also, if you have imaginaries, you're not going to be able to factor it. So you revert to, generally for me, zero factor is plan A, and quadratic formula is plan B. We will talk about these others also, all right? Well, I can't say this anymore. I've always said, I don't know anybody who would choose completing the square. No, I actually had a conversation one day a couple of years ago with a bunch of guys. We'd gone to do some hurricane cleanup after Hurricane Laura. I don't know, maybe it wasn't Laura, something else. Anyway, so they were all chainsawing and dragging trees out the road and everything. At the end of the day, we were talking something, and somehow the topic of math comes up. And so somebody says, yeah, I pretty much never use that quadratic formula again. And another guy says, I've used it. And he said, but wait, I really prefer completing the square. We literally had a conversation with random people. Okay,
It
so
feels like it takes so much longer.
it does. It takes longer, but I'm glad you've been exposed to it. So did y'all do that some?
We did a little bit of it in algebra 2. Like we had notes just like this actually and had the methods.
Good. I'm so glad that she went that route with you at some point. And we will dabble with it in quadratics, and it's not real pretty in quadratics. But in chapter 2, we are going to be graphing circles, and there is one place where you absolutely have to use completing the square. You actually complete two squares in one problem, but the numbers are a lot friendlier there than they are here. The book kind of goes ugly, but you need to know ugly, because if it comes up in calculus, you need to have that tool in your toolkit. So anyway, here's the general guts of it. You want to set the equation equal to 0 and try factoring. You want to, if you have binomials, look to see if maybe there's a GCF or dot. Most of the zero factor methods in this book are trinomials, but we will come across problems in the next days where it might be a binomial and there is a GCF you can factor out, or maybe it's a difference in two squares. All right, so we can make conjugates out of it. Now, if they are trinomials, you want to have ax squared bx plus c, that format. And I really recommend that you never have a leading negative here. It is like almost impossible to factor with a leading negative. So either factor out the negative, or if this is negative, move everything to the other side and put the 0 in front. Okay? So let's just jump into some of these problems. Okay? So bust out your composition book. And we are going to section 1.2, and I got way too much stuff happening here. And this, no, not 1.2. Okay, so I just want you to know 1.2, 1.3, see the packet. All the notes that we did for 1.2 and 1.3 were in the packet. Okay, so here we're doing 1.4 quadratics. Technically, it's quadratic equations. So, Unit 1, all sorts of different equations. But not all of them, because Unit 2 continues with more equations. Unit 3 picks up a few more equations. So, we solve all the types of equations here. All right. Actually, Unit 2 gets a little more into graphing. All right. So, now, method 1. Is our zero factor method. And it's called that because you set it equal to 0 and you factor. This will be problems 13 through 18 out of the book. And we'll do just a few. No, actually, we're not going to do a few. We're going to do exactly one of these because this is something you're probably pretty good at, especially if your factoring is starting to improve, okay? So, I don't trust copying them from my notes. I'm going to copy it from the book itself. We're going to do number 18. And it comes to us looking like this. Negative 6x squared plus 7x equals negative 10. Well, with the zero factor method, you need to set it equal to 0. But, oh, let me tell you one other thing. Can you pull these back real quick? I need you to know some terminology that I'm going to use so you get used to it. In these trinomials, that this is the standard form for a quadratic, there is a name for each type of term. So, do you know the names of any of these types of terms?
Isn't the C a constant?
That's a constant. So that means you have a number that does not have a variable. I will use that word a lot, and you need to be very, we use a lot of vocabulary and you'll get very used to it. Okay? So you kind of answered this for me already. I said, what makes a quadratic? And you said an x squared, right? So this is your quadratic term. So that leaves, what's the other one? Okay, so watch this. If I covered this up and I removed the quadratic term, this would look a lot like mx plus b, wouldn't it? What type of equations y equals mx plus b? What kind of graphs does that make? This is your linear term. So in 1.1, The title was Linear Equations. There were no higher exponents in that. Okay, so now my quadratic term is negative. I don't like that.
So the lower.
Let's just put the 0 in front and move everything to the back. So what would it look like?
0 equals 6x squared minus 7x plus, or minus 7x minus 2.
Okay, your basic algebra skills are very strong. Okay, so I didn't get a chance to see much of what your algebra looked like last year, but what I've seen in just this week, I am absolutely confident
Algebra is
that
life.
I'm very confident that you are made for this class.
I love algebra.
Good. I know
If
you
you
were
put me in
looking
geometry, I
Well, trig is kind of like
I
geometry on
struggle with
steroids, but we do so much algebra in our trig. So
I think the only thing that I really struggled with in geometry was like, I think the only thing that really I got stuck on was, I think it's called proofs or something
Okay.
like that, where I have to like, why am I proving that it's a triangle I'm looking at? It's going
okay,
to
so we do a lot of proofs in trig,
Yeah, I know.
but I'm
that's why I
hoping
was scared.
so I love proofs, and I hope to share
Maybe
that
you can
with
help me
you. I think,
understand that
yeah. So anyway, okay. So first of all, is there a GCF? Because I sure didn't bother to take one out. Okay. Second, this subtraction sign here tells me I'm trying to get my outies and the innies to subtract and be a 7x. I usually will use a t-chart if there's a leading coefficient. There's more than one way to break down 6x squared, though. What would you like to try?
Do 2x and 3x.
Okay, and I would go that route too, from experience of factoring thousands of these in my life. I tend to find that the books are more likely to go with the ones that are closer together than the one and itself. It does happen, like 6 and itself, but 6 is itself, 6 and 1 is what I'm trying to say. But this would be the one I'd try first. Okay, so what's some stuff that goes into 10? Keep in mind, we're trying to subtract and get 7, so we got to get higher than 7 so we can subtract and come down. So what goes into 10?
5 and 2.
Okay, so if we try it this way, 5 and 2, and we let this represent your outside loop, and we let this represent your inside loop.
So you get 10.
Minus
So
10 minus what over
10
here?
minus 6 equals 4.
That's not it then. So
So can you do 2 and then 5?
we can turn that around. 2 and then 5. Okay?
So 2 times 2 is 4, and that's 15, so you get 11.
Okay, so that's no good. So what else goes into 10?
21.
Okay, so we could go 10 and 1.
So that's 20, and then 3, and minus 3.
And going 1 and 10 is even worse, right?
Yeah.
So we have exhausted everything on there. Although I was really hopeful looking, but I hadn't looked back at the answer from last year, so that means this t-chart didn't work. So we,
could do 6x and then x.
yep. So sometimes there's a good bit of trial and error here.
So then you could try 5 and 2.
Okay, so 5 and 2 is going to be way huge. So we want to try
2, 5.
Okay.
So that gives you 12, and then 5, and 7.
Found it. Okay. So as you pull things off your t-chart, whatever you wrote, the top order, do not change it when you bring it over here.
Okay.
And then
the
this
2 goes
loop,
on the other side.
2 goes at the back. So, whoops, and the 5 is not an X. Okay. So now, with subtraction, you have to be really careful. Don't just look at these numbers, the 5 and the 2, and try to make one of them negative. Look at the products. You had a 12x and a 5x. Where does that negative need to go? Which one of these would need to be negative?
On the 5.
Okay, so hang on, be careful. On the 12, so it's which product needs to be negative? Because I'm combining a 12x and a 5x to get a negative 7x.
Oh, yes.
Okay, so if that needs to be negative, where does the negative need to go?
After the x, or this is
Yeah.
or yeah.
Because it needs to be on the 2 times 6, not on the 5 times x. So I have students that a lot of times will go, oh, it's negative, I'll put the negative with the biggest number. The biggest number may not have been the biggest problem, and that's where you need it, okay? So now, we've got it set equal to 0, and I've got all these loose little loops here. Do you recall how to go from those parentheses to the solutions? Okay, well, let me give you a quick refresher of what's happening here, and I'm going to show you the long way, and then we'll see the shortcut, because you'll do it so many times, and we'll do it many times. Okay, what you technically are doing is you are setting each factor equal to 0 individually. So you're setting 6x plus 5 equals 0, x minus 2 equals 0. But you'll do this enough that you're not even want to write that down again. This one's real easy. How would you get your epsilon?
You add it and
Yeah, so you do the opposite of the constant, because the constant would move it back and change its sign, right? So, and because, wouldn't a positive 2 minus a 2 give you a 0? But this one's not so easy to look at and say, well, what would I multiply 6 times and add a 5 so that I get a 0? But watch what happens. The constant would move over and change its sign, right? But what would you do if there's a leading coefficient? Yeah. So if can I make one up and see if we can pull it out without scratch work? Okay. So let's say you had 4x minus 3 times x plus 7 equals 0. What would this x be?
that would be negative or positive 3 or 4.
Okay. And what would the other x be? Okay, so we're good without having to factor a whole bunch more? Okay, so that was just a little example, and we are leaving method 1 because you've done a ton of factoring lately. Your factoring is probably pretty good, and you've gotten a quick refresher on setting it equal to 0. We don't need more examples. So then we're going to go to method 2. So back in my notes, different yellow highlighter. I have no idea where the one that I was using a minute ago went. All right. The square root method is my go-to method if I don't have a trinomial. If there is no linear term, whoops, like this, if I had no linear term, then I could move the constant over. I could divide by anything that's in front, and then I could square root it on both sides. Now, I'm just going to give you full disclosure. I'm about to get really annoying because when you use the square root method, the fundamental theorem of algebra still says you should have 2 answers, and I get a lot of students who only give me 1 answer because they forget a huge step. So, I will help you remember that step if you won't remember it on your own, okay? So, most of the time, the square root method is a binomial. We will, after we play with a few of these, see something else where the square root method can help, which is really a precursor to the final steps of completing the square. So, completing the square means taking it and turning it into a problem that you can use the square root method on. So, we'll look at some of both of those. So, I am going to tell you right now. So, you want to get the square term and the constant term separated so that your constants are on one side and your square term is on the other side, right? Then you square root both sides. Now, here's my warning. And I've done this for years because I have students who don't do it. So, when I say, let's square root both sides of the equation, I will count to 1/2 of 1 second, and then I will, if you do not tell me that you have to put a plus minus, remember that from last year? If you don't quickly tell me you need a plus minus, I am going to start beating on the desk and saying very loudly, oh my stars, I just square rooted on both sides. What am I going to do? What am I going to do? What am I going to do? Okay, so now, it's all up to you, baby, because you are the class, all right? But, and students, I have had students who have loathed me for doing that. Like, stop. And so, but then I had one who just whined for weeks, and then on the test she forgot it. I can't do more for you, dear. You know? Anyways, I am literally going to try to beat that into your head, okay? So, method 2. Can you even see where I am? Okay, method 2. Square root. And then put a little note, plus minus, because it's a big stinking deal. Because otherwise, you'll only get one solution, which doesn't fit the fundamental theorem of algebra that the exponent tells you how many solutions you've got. All right, these happen from 19 through 30. And at first, they are just your typical quadratics where they just don't happen to have a linear term. So, let's look at a couple of them. I have to make you work to get them in form you need. Number 22. I have got 48 minus x squared equals 0. Well, I need to separate my quadratic term from my constant term. So what you going to do? Because we don't want to have a negative quadratic term. 48 equals positive x squared, right? And then what are we going to do?
Square root both sides.
I'm going to square root of one side. Oh, I start.
Thank
Okay.
you.
So I will have a plus minus here, right? But does 48 square root minus?
Yes.
Is it a perfect square? Well, let's go find out with the factor tree. Think of something that goes into 48. Yeah, that's good. Okay, which one you want? You've thought of all sorts of them now. It doesn't
I
matter.
know.
So pick one.
It's 12 and 4.
Okay, 12 and 4. Okay, 4's got some little factor buddies inside of it, right? What goes into 12?
6 and 2.
A 6 and a 2. Got another 2 there. What goes in 6?
3 and 2.
Okay, so who's got buddies?
The 2s.
Okay, so we got 2 pairs of 2's that have buddies. So what number are we taking on the outside?
3. No. 4.
4, because 2 times 2 is 4.
4 and 3 on the inside.
4 square root of 3, right?
Yes.
Okay, and we are done.
Perfect.
Okay? We're going to do another one like that. We're going to do number 24. And this one's already set up all nice and pretty for you. X squared equals, and my constant's on the other side. But check out my constant. So, what do we need to do?
Right, square root it.
On both sides?
Put a positive and a minus.
Okay, so I definitely have a plus minus to get me the 2 solutions. Fundamental theorem of algebra says quadratic should have 2 solutions. And what are we getting out of that house? Well, we're going to get that negative out.
Well, yeah, that too.
That too, right?
Yeah.
So yesterday we did a whole lot of stuff in scratchwork, and then I forgot to put my eye. So watch me. I'm just going to leave myself a space, and I'm going to put my eye right now because I see the negative first, but I have to put it last. And if I get busy on the other part, I'm going to forget the eye. So I'm covering myself right there. Is 400, was that a perfect square? Did you have to memorize on that number?
Yes, it is. Isn't it?
If it has 2 zeros on the end, okay, is the number in front a perfect square? So what's the square root of 4? So if you put a 0 on each one of those 2's, we got enough zeros for each one. It's 20 times 20. Yeah, make sense?
Yeah.
Okay, so
That's helpful.
I'm done. All right, and then we're going
When
to
it looks so complicated, you're just like, I'm done.
I am. Yeah, it's ugly, but X is alone, isn't it? Okay, let me see. We're on to number 30. And I have just about the same amount of room. I should be here. If you're real close to the bottom of your paper, you may need a little more space for number 30. Okay, so number 30 is not exactly like this. Number 30's got some parentheses and it's got a binomial that is squared in it. And this is what you are going to want to make your completing squares look like. All right? So number 30 comes to us in parentheses. I have the binomial negative 2x plus 5. That entire quantity is squared. And it's equal to a negative 8. So the other day, did I use the term SOBs in here? Okay. So when we do our completing the square, which is our next method, we're trying to get to what I call the SOB row. The SOB row. So it'll be an SOB, square of a binomial, with a constant on the other side. So what I'm showing you now is how you finish completing the square problem. Because you don't generally just run across these. There's a few of them between 19 and 30, but they are really practicing a skill you're going to use next. So,
SOBs, you square the first one.
But we're not going to multiply it out. So we're going to use, because what method are we using right now?
Oh, we're doing the square root.
Because we're trying to,
So you
we're
square
trying
root
to
the whole
solve
thing
it.
and that takes it away.
I put a gigundo square root on this side and a gigundo square root on this side.
Put your plus and minus.
Okay, so over here I definitely have a plus minus, right? What happens over on the left side?
The square goes away.
So then I don't even need my parentheses anymore, do I? So my negative 2x plus 5 says we are free. All right, so we have freed them and we can move them from side to side now. But over here,
So you can take out an I.
I can take out an I. Can I take anything else out? How do we shortcut an 8? So I always tell my students with the 8, yes, with an 8 you can chicken foot it. Instead of a branch, you've got a little chicken foot going there. So we have a pair of 2's and we have a 2 that doesn't have any friends, right? Okay, so we all come, where's my I? Jeez Louise, where's my whiteout?
I reminded
You did, but then I didn't know exactly where I wanted to put it, and then I got busy with the chicken foot, and see, this is my downfall frequently. We would say 2I square root of 2. Is that the order you would have thought to put it? Good. You're apparently more efficient with your I's than I am. Now, have we finished? Because X is not alone. So what's the next thing that's got to go?
You can divide by.
Don't divide. Get rid of anything that's added or
We'll
subtracted.
subtract the 5.
So let me advise you, put the 5 right before the plus minus. You don't want to lead a binomial with a plus minus. You want a plus minus in the middle of a binomial. So when I bring that 5 over, I'm tucking it in before the plus minus. I mean, it could be, you just never see plus minus 2I square root of 2 plus 5. The risk is that your radical goes so long that it looks like the plus 5's under it. So you're better off putting it here. So now I have a 2x is equal to negative 5 plus or minus 2I on the square root of 2. Now, I'm going to have two solutions because the plus minus accounts for my two solutions, doesn't it? But am I done? So now what do I need to do?
Divide by -2.
Okay, so now.
So do you separate it out?
I love this. You are so brilliant about that. Yes, ma'am, you do separate it because I'll take off a point if you do a gigundo division under an I. Now, if there was no I and you wanted to do a gigundo, okay. But the I makes it a complex number and we want to separate it. So we have x. Now what's going to happen here?
It's going to take away the negatives.
Okay, so we got 5 over 2. Now, we can cancel out the outside 2's over here, right?
Yes.
But what is that negative on the bottom going to do?
Isn't it going to divide?
It actually changes your sign, but you've already got both signs, don't you? Yeah. You have a plus and you have a minus. Do you need to write it as a minus over a plus? No, you're just telling the world I have a plus and I have a minus. If I change both of my signs, I still have a plus and I have a minus. So I don't really need to account for that negative on the bottom. And so what still exists over here? There you go. Now, in the trig semester, you will actually learn there is a minus plus sign. So there's
So
plus
it's the
minus.
opposite?
So it's in a particular formula that the original problem has a binomial that's either a plus or a minus, and then you convert it, and the sign in the middle needs to be the opposite. So on the other side, it says a minus plus to let you know if it was a plus, it becomes a minus. If it was a minus, it becomes a plus. So it serves a pretty good purpose there. And then there's a similar thing that you don't change it, so it keeps it as a plus minus. All right, now let's do, no more of those because we're going to do a bunch of these in the middle of our method number 3, completing the square. So, I'm going to front load you my steps, okay? And so if you ever need the steps, they are listed here. Method 3, completing the square. All right, first of all, if you have a leading coefficient in your trinomial, if your quadratic has a coefficient, that is not helpful in any way when you are completing the square, so you've got to get rid of it by just dividing everything on both sides by that number. That's when this becomes kind of ugly. All right? Then you are going to create what I call your blank row. All right? So you're going to move whatever constant they have over to the right, and it's going to leave a hole where the constant goes, and you're going to put a blank. And your goal with completing the square is to pull a number out of the air that goes on that blank. What the heck? But if you pull a number out of the air on one side, it goes on the other side, right? So, still front loading, you're going, oh, yeah, I don't even know what you're talking about, but front loading, okay? After your blank row, you have your SOB row, which is going to look like the last problem. So a square of a binomial on one side, a constant on the other, and then you use the square root method. Now, did that help you understand completing the square? No. I want to help you understand completing the square by understanding why they do it. Okay? So problems 31 through 42 are completing the square. Now, there will be many times after lesson 1.4 where you can use whatever method fits you and makes you happy. But next week on the 1.4 quiz, there will be a problem that I specify for every one because you have to prove to me you know that method. Okay? So, completing the square. Let me explain what this is truly about, and then maybe they'll make more sense. So to do this, we're going to go back to what we know about an SOB. So I'm just going to pop an SOB right here on paper, x minus 4 quantity squared. And see, that's another thing. When you get to solving quadratics, completing the square is not in that, but with your honors, you're probably going to want to source something on completing the square. Okay? All right. So, SOB, tell me the 3 steps to going straight from the square of a binomial to the trinomial that is associated with it.
Square the first one.
Okay? Square the first. Okay? So, x squared vx squared, right? Okay. What's your second?
The second one is multiply the first and the last, and then multiply by 2.
Okay, so first times last times 2. You will see every bit of these steps because completing the square is undoing this. You'll see it, okay? So what would the first times last times 2 give me?
Negative 8x.
A negative 8x. And then where do we get?
You square your last.
You square the last, which would be?
16.
Okay. What kind of a 16?
Positive.
positive 16. So when I teach this to Algebra 2, I make them memorize this as plus square the last, so they know that last term is always positive. Okay, what if I gave you a trinomial, okay, and asked you to go from the trinomial back to the SOB? Could you do it? Okay, so if I gave you this, you could go, well, that x squared came from an x, right? And you could say,
multiply to get 16, the x.
Yeah, but here's what I'm going to do. I'm going to forget to give you the complete trinomial. That's completing the square. So I'm just going to put a blank right here because the constant is not known to you. And I'm wondering if you could figure it out. So underneath here, so here's my blank row, and here's my SOB underneath it. What do you think was right here in the SOB? An X, right?
And then the plus sign.
Now how do you know it's a plus sign for sure?
Because both of,
okay, it's because this one's a plus. So these two, if the binomial has a minus, the first sign will be minus. Okay. If the binomial has a plus, the trinomial, the first sign will be a plus. Okay? So how could I use the middle step here to work backwards to figure this? Like if I hadn't had that, how could I have used this to go for that? First times last times 2 gave me that, right? So
divide it by 2.
I would divide it by 2. So all I have to do is divide the coefficient by 2.
So
it's 6. Oh, now that I know the last, can I fill in my blank? What is 6 squared?
36.
So that's what completing the square is made out of. So what we're trying to do is get this SOB so we can square root both sides. So I've only shown you half of a completing the square problem here because it actually is an entire equation where I'm trying to solve for x. So I am going to give you an example. I'm going out of order. I actually have grabbed one of the odd problems because I do not want to start you with the most difficult and convoluted example. I'd like it to be kind of namby-pamby. So I'm going to give you problem number 35 as an example. So here's what it has. It has x squared minus 2x minus 2 equals 0. They give you a trinomial. Now, I'll tell you what. Not every trinomial comes from the square of a binomial. But we want to make this into an SOB. But this is not the constant that does it for me. So if I'm keeping my steps handy, you don't have to look back at yours, but I'll kind of show you mine. My first step in completing the square is 1, get rid of any leading coefficients. I didn't even have one on the first one, did I? Step 2, create a blank row where the constant they gave you is on the right side. So we need to chunk this out of the way because that's not the constant that I need to create an SOB. So I'm going to create a new row. This is going to be my blank row. And so I am going to leave plus a blank where my constant needs to be. Because in an SOB, it's always plus. Because if you square negative, it's positive. If you square positive, it's positive. So I can always put a plus in front of my blanks, right? And then I have chunked.
Then it's negative 2.
Well, positive 2. But this blank is going to be filled with a number that I'm about to pull out of the air. How can I legally pull a number out of the air and just put it onto this side of the equation? my best algebra tools, I can do that all I want. But I better pull it out of the air and put it on the other side as well. So do you see why I call this my blank row? There's lots of blanks, right? Now, I don't know what number I'm going to pull out of the air until I go to my next row, which is called my SOB row, and I build myself an SOB. And that's what we just did a minute ago, isn't it? So, what's in my SOB? X. What will this sign in the middle be? Negative, because I'm dividing -2 by 2. Because remember, it was first times last times 2.
Yes,
I'm dividing this by 2. So, -2 divided by 2 is, I have completed my square. I've completed my SOB, which means now I have information enough to fill out my blank row, don't I? So the number I needed to pull out of the air was 1, but to make it legal,
to do it to the other side.
So now, what's my constant? And it looks like that last square root method problem now, doesn't it? So the whole beginning is just to take a trinomial and make it look like an SOB. That's the whole thing that you're doing in completing the square. Now, we let the square root method take over. So, I'm going to square root the left side. And I'm going to square root the right side. So, on the left side, it says, I am free. X minus 1 is free. And on the right side, I've got plus or minus. Anybody coming out of that house? Nobody's coming out of that house. Plus or minus square root of 3, right? And so, am I done? Where am I going to put that 1? So it's going to look like x equals
1 plus or minus square root of 3.
Am I done?
Yes.
X is alone. I am done. So, does that give you more of an understanding of the why? Did you ever really know why you were doing your steps? Okay? It's all about SOBs. So, now, we probably aren't going to get the next problem done, but maybe we can copy it down. The next problem is we can just write down a 32, and I can put my little start here sticky note. Don't start on this homework assignment. Knock out more stuff. Come back to me Monday and help me erase a lot of things off of there. I know it's going to be a busy weekend. But you're still in recovery mode from the Rona here. But, okay? All right. You are like a daggone sponge. Just get things caught up. Because I'm going to be putting more stuff on the list.
I'm going to knock it out this weekend so we can
have a
clear board for the most part.
Yay. I can give you new stuff.
Yes.
Have a good weekend. Howdy, how are you?
I completed my homework check and 2.1 assignments. Should I turn them in now or Monday?
Oh, go right ahead. It makes my life easier because I can kind of grade a little bit in advance. Okay, we have the teeny tiniest piece of homework of notes to take and finish up. So be ready for the teeny tiniest little piece of notes.
Hey.
Oh.
Once I finish my personality, we'll go work on the
Mr. Stewart, I might have watched the video and got that part.
Because you just couldn't stand it, could you? Actually, Mike could have figured it out without me.
I did, but I checked myself.
Alright, I love that dedication. So is your lookalike buddy back? Oh gosh, hopefully this weekend will be enough recovery time for her.
Hi, how are you?
Or they're both on your desk or the.
Okay, so she'll
Dude, my leg was there.
CMHW. So a CMHW should be on pen, paper, and Caribbean. So, okay, no, these were just the options. Okay,
Yeah.
for 2.1, I don't have a homework check for the 2.1 opt. But did you do those even? Yeah, so that stays there. And sometimes I do a homework check, and sometimes I don't. So I keep it kind of random just to keep it guessing, so you do it. But yeah, if it says CMHW and it's even in the trade, you already put it in, right? Yeah, and in fact, I'm gonna have both of y'all move up a seat because we've lost Tyler.
And we lose everybody.
We lost people, but we also gained most of my pre-cal students, so I'm still pretty close to the number of students I started with.
What are you reading? What are you trying to read?
Huh.
He's reading your expert personality. And if you finish that, you need to do your all.
She said even if you didn't finish your
Roy reads them.
you're not gonna have to work on it.
Take it, Roy.
I did it this morning.
Oh, Josh, I wrote you in ink, but that's okay. I'm still moving you up one, and then I'm gonna white out the other.
We gotta finish our notes, guys.
I know. Gotta find out what happened. The rest of the story. Okay, Josh. No, not Josh. And Carson. Stop whistling.
Oh, man.
Okay. Elise, can I get you to shut my door for me, please? Because I'm being all lazy and stuff. Okay. All right. All right, real quick. I'm finishing up these notes, okay? So, if you recall, we've already looked at set M, which has a 2, 4, 6, and 8 in it, right? And then at the beginning of part B, it defined the universal set, which by the way is the very same universal set that's going in part C. So we wrote out the universal set, which was the set of all, what's that? Okay, yeah, set of all D such that D is an element of the natural numbers, and the natural numbers start with 1, right? But it also has to be less than or equal to 10, so we listed them. And I think I was doing this highlighting right when that bell rang. And then that particular yellow highlight, it just ceased to exist. It actually fell to the floor. Okay? This says find M prime. What does that little mark that we're calling prime tell us to do? Ooh, you've got resources. Look back. It's called the complement, and what does it mean?
It's the opposite of like whatever's not in the.
Whatever's not in the set. So it's the rest of the elements from the universal set, right? So these elements 2, 4, 6, 8 were right here, weren't they? So what would be the complement?
1, 3, 5, 7.
The 1, the 3, the 5, the 7, the 9, and the 10, wouldn't it? Okay, so 1, the 3, the 5, the 7, the 9, and the 10. So does that help you have a clearer understanding of what a complement is? Okay, now, what does the next question ask me to give? The cardinal number of, I know it's a cardinal number and not an absolute value because it's going to name a set in there. But which set does it name this time? M prime. The M itself had 4 elements. What does M prime have in it? Anytime you are giving me a cardinal number, you are giving me a number. I was grading a paper today that asked for the cardinal number of an empty set, and they drew a 0 with a slash through it. That's not number. That's a symbol. Yes.
Wait, how do we know if it's asking for the code?
These symbols. Yeah. You didn't watch those videos from yesterday, did you? Okay. So if you go back to the notes we had yesterday, you're welcome to copy my notes, but you may want to watch the video to get the explained details. So anyway, that wraps up our 2.1 notes. So let's talk about what needs to be happening today. First of all, Emily's not here, so I can't hand her this. I've been trying to pass these papers back to Emily for the day. All right, so I've got, here's my best source for this. I've got a small handful of you that have got to do College Bridge. All right, so here's what's happening. Miss Monso is the only person that I know of in this entire school district that can put people into College Bridge right now. All the people who could do it last year no longer are here. Anyway, she can still do it. So, all of you who need College Bridge, she should have put that in, with the exception of somebody, and I have that note over on my computer, and we'll have to see. I'll be talking to one of you about that because I don't think it popped up yet. But anyway, if you are not college ready, then I told you yesterday that expert personality thing needed to be done. Put that puppy up in the tray because you're going to be on College Bridge this whole period. All right? If you're not sure how to log in, I will answer those questions for you in a second. But if you're doing College Bridge, I need you to have a spot for your scratch work. It involves scratch work. You are not, if it asks you something about geometry and you're like, I don't remember that formula, I have no problem with you going and opening your page and asking Google what's the formula for blah, 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 blah. I don't mind you doing a little research to help you know what you're doing. However, I do have a problem of you going over to Googling what is the answer to this question and expecting that to happen. Do you see the difference between those? So if you're doing research to help you understand so that you can do the math, okay? Another method to get help is to ask me while you're in here, Ms. Stewart, and you explain this to me. Some of the problems, occasionally, are so easy you can just look at them and know the answer. I walked past the desk today, and it was asking a kid to round, and it was multiple choice. It didn't need to write anything down. That's what you were doing on that assignment the other day. I get that, but right before that, we had a problem where we had to add some fractions, and we had all sorts of scratch work. I want all of your scratch work as you're working on College Bridge to be, can I steal this and pretend it's you? In your composition book that you're doing your other work. So grab a chunk at the back, maybe 10, 15 pages, I don't know, and write College Bridge there, and that's where you always do your scratch work. Last year, I had students who would ask how to do something, and I would sit down and, write on some paper, an explanation, and in the period they throw it all away, and then 2 days later it popped up again, and they're like, no, I don't have those notes. Well, really? I just gave you the whole explanation. You threw it away. So I want, anytime I help you, we'll put it in your composition book. Any scratch work you do goes in your composition book. This is how you can help prove to me that you are actually doing the learning here. If at some point I become suspicious that you're having somebody else do this work for you in some other place, and you can't prove to me that you actually have the understanding, I will restart you. That's why I didn't want to restart you this year. I do that, but I would make that happen. I had some students last year, one that I'm pretty sure a parent did all the work for him, and one a girlfriend did all the work for him. That's not gonna fly, okay? You've got to prove this college readiness, okay? So, anyway, go ahead and see what you can do to get into that portal. And grab your computer if you need to be working on that, because that's what you're working on Fridays. All right, those of you who don't have to prove that to me, if you have not finished your personality test, bust out a computer and do it. Your CMHW that's due Monday, do it and turn it in when you're done. It helps me a ton if you have it early. And then do the odd problems in your composition book. You may only sit and twiddle your thumbs and do nothing if you can show me all of this is done. Okay? Alright. I saw her hand first, then I'll work my way around.
I've got all of this. Can I go into this?
Turn that in and you may twiddle your thumbs. Yes.
So I'm having a new class for like my business addiction. Can I do a test out?
Do it. Love that. Love that. I would love if you are at the thumb twiddly stage, if you have some other college course or homework or something else, I would really love if you were doing something educational. Really, really would love it. I am not okay if you think you're gonna watch YouTube videos. That's not happening.
I will pull my phone out and walk on my phone.
Do you have to get the duo digging? Yeah, you may. So grab your computer.
Do I need to show you keys also? Or did y'all get that somewhere else? She said you told me.
I think, hang on. Hold on. You don't have to show me PSI because your SAT score was high enough to qualify you as well. So I found some proof. I couldn't find your PSI, but I could find.
You gotta have like a 9-7.
Well, so the math part had to be 5:30 for the math, and you were there. So, anyway, so you are fully ready. Okay, yes. And then okay, so you got those done. So are you on the stage? Okay. So do you have any more education? I don't know.
I don't think you can hear past you.
Was back on the side of $1.
My computer is always this. So I feel like I can do it.
Okay,
Like,
you grab it.
So I'm kind of
I don't, okay, you need, so 14's open now, okay? So for the time being, why don't you use 14 and I'm gonna put in a work order. What is this, sir?
Oh, I was looking at all the homework I had.
It's really hard.
Okay, well, I was looking.
Yeah, there's a lot of numbers, but,
Once you start going, I can just sort of. We also attach more than I am. And that's hard.
I like that thing.
I can never use it. I always try to use it.
I use mine, but then I leave it everywhere and I forget and don't look at it.
I have to make myself like. The only thing I'm bad about is going back and looking. Like I'll write stuff down and do that, and I forget to go back and look. You know, I'm coming to the lower in the second period.
My second period.
Yeah.
Miss, yeah.
Why'd you get married? Because I was doing like ingenuity, but they had me on like 2 vacations. Management, and I couldn't do that. Because it's involved in my assignment. Oh, that's what you were doing in there today? This morning? Oh, yeah. I was wondering what I was getting all those. That was a handout.
Someone, yeah. Do you want mine?
No, I have one.
I didn't get
I just finished this study.
Okay, you may be my person, give me just a second. Okay. All right, let me, okay, you may not need an email. If you are already in the system, then, okay, Elise, you're the person that I don't know. See if you can get in to the College Bridge and if she's been able to add you. She wasn't, so what she told me was you and 2 other people had not logged in for some amount of time and it had gone inactive. And she said if you will log in, then she can add you. So I don't know if we can get that happening. You, wait, who is Abby? She should have added it to yours if you can log in. Can you log in?
I can try.
Do you know where to go?
Oh, wait, yeah. It was on.
Okay, so click your goals.
This one?
Yeah, so, okay, go. Okay. Hey, okay, we're in, right?
Yes.
Okay. Okay, you in? Alright, so I'll be wandering around answering questions, so, are you able to get in?
I can log in, I just need to.
Okay, so that, so I think. So. I will send her an email, and maybe she's in her computer, and she'll catch it right away, and she'll do that. All right. So in the meantime, you want me to just keep that around and try again, maybe in 10 minutes or so, and remind me, and I'll check my email and see if she sent me anything back. And have you got your CMHW 2.1 done? That gives you something to do. If you want to just put that on my desk so you don't have 15 things on your desk, and set that on my desk so it's ready to look at again, out of your way. Okay, and I've got books back here.
Can you check if I did this one?
I can't.
I'm not sure if I've ever done it. Okay, I'm sure if I just did it.
Can you carry your giant book with you? Since using a calculator is an option, I have no problem with you using that. Their rules. Their rules. You see where something has to go? That's when you try and stop. Just click a little bit, go to. And so then it's click the start diagnostic. This is where
No, I was about to.
You just get
And the one
the
that
round
the other
bag,
day, I
the
made
thing
it
that
80.
we talked about it before, and thought that they were
Especially with different walls.
not forever.
She's like a strict back.
Okay, y'all have gotten loud suddenly and you really should. Y'all, you're allowed to use a calculator on College Bridge, and a whole lot of the problems that they give you are problems that this calculator is programmed to handle. So like order of operations, type it all in. Fractions, it handles fractions, so take advantage of the fact that you can use a calculator. That is literally how come. This is, that's the stuff.
I really don't have anything. Like that.
So, don't the person that is teaching
I don't think so. It really doesn't come much of anything. Like the actual book was probably nothing you should. I think I saw it. I tried using it on something.
it's not, so it really.
Little bit. It's like a required book. Just like scanning. Okay, we probably.
Physical stuff, very long.
Yeah, because we got one of the last ones.
Yeah, because it's a 4-hour science class, so it has a 1-hour science and 3-hour, or 1-hour lab and 3-hour.
There's, and I go to the council one next.
Yeah, so I took that in 1981. It's basically
Probably a lot better.
Professor O, she wanted, and she was like a real rock, you know, so this summer she went to New Mexico, or New Mexico, she and she went there to work in the anyway, she was so sunny up there all the time. This is a class.
Probably a lot easier in person than online.
It was, and it was just, and the labs were neat. And I remember I remember so much class. So then, that was the one point. The next year, I did one. So I took seven.
Oh, yeah.
And, so this is, and it was the first, desks full of, and, it was more having to memorize the Jurassic World and same thing and then it's always, you know.
We put those insurance, like, one of those, like, once you flip through that section and then paragraph by paragraph.
We can like.
So like each, like where each thing talks about.
Yeah.
And it's so hard to just online book, it doesn't tell you anything.
So you gotta have, so you might wanna think about on Fridays when you look at the, because you have a little spare time.
I'm pretty sure it's.
I'll get you next, cause I'm gonna get next. I'm gonna show you one next, can I show you something really cool? Put your hands like this. Okay, so you've got hills in the back, right? So some months you take the hands, all the rest are doing. February doesn't have 30 days, and the one that has 30 days, February has 20. I don't think that, right? So, so I do this because I learned at home when I was a little 30 days last September. All the rest of the time, because I can say that they were. Y'all, I'm gonna show this to everybody, just in case you don't know, because a lot of people have asked me about the question with, do you know which months are 31 days and which months are 30-day months?
No.
You just know that? Here, look, watch, I wanna show you something, it's kinda nice, okay? Put this, if you put your hands together like this and start counting the months with 31s will be up high, and the months with 30 will be down low. Now, what's the one month that doesn't follow that rule at all?
February.
February is a short month, but it's shorter. You know why months are not all the same length? It's 365 days does not divide nicely by 12. So that's handling all the remainders. So hold up your knuckles for me. So I'm starting with the high knuckle here. January is high, 31. February is low, it's either 28 days or on leap year 29. Come back up, March, 31 days. April, 30. May, 31. June, 30. And then you've got two knuckles next to each other because July and August are both long 31 months. Then it goes down for September, 30. Up for October, 31. Down for November, 30. Up for December. Have you ever seen that?
I just gotta tell you something.
So, anyway, so that may be the most useful thing you learn as a senior this year, I think.
Probably so.
And maybe teaching that to your kids one day. So did that help you?
And it's the Mary Society. What's 20 times 17? we still can use the data. Right, yeah.
So do you know how to put that?
Yeah. Yeah, I forgot how to put this.
Or like to make it a decimal or something?
No.
Okay,
Just
your
your
calculator program so
Oh,
that
that's not
what
allowed.
you see is cards and with the slide.
Okay.
Okay, so.
Different websites.
Yeah, they are incredible.
Maybe I gotta rewrite this one. It's gonna bother me that it's slower. So I'll have to rewrite it.
I got it.
All on the same page.
Okay, Elise, whenever you want, you're good to go. So if you want to finish a problem or something. And y'all remember, the CMHW 2.1 is due Monday. So if you're working on College Bridge and it's not done, you do have some homework this weekend.
Describe the sex. So like it could be like, say you are and then say you are a member of. I said, which one is that the? It's number
Practice. Is that the one where it is
Two members.
two
Two sets of members.
sets that you're in?
Yeah, okay. Oh, yeah.
So when you think when you're in the staff,
I
that's the
said-
Chick-fil-A and Orange.
I said, I have a set of last name that starts with R, and I am a set of 17. I like that.
And I would say I'm in the set, because you aren't the entire set, are you?
Yeah.
Just there.
Let's leave your idea for this.
So that's what it is, is it all the,
Is it? What's number 5 say?
no.
Does number 5 say no?
Yeah.
Compare 5 and 6.
Well, that was all we did. What are the braces?
What is that?
She's sick. Who? Yeah, so she'll be back. Something. Because cousin. Yeah, well, this one was just in a snap and she had her eyelashes done. She was all up here with it one day.
Thank you.
So she was not coming?
Oh, yeah, when you check.
Well, no,
I didn't say
no.
what it I'll find this question. Oh yeah, I'm pretty good. I'm gonna do the clean paper probably later when I get home.
Yes, inside.
Or if I finish early, I'll do it. it's 11:08.
Also, we can't even listen to music while we're doing our schoolwork anymore.
What's the difference?
Everybody's going off to this.
I don't know what I'm doing. Right now, it's fucking weird geography.
Wait, yeah, I really got it. So if you do, yeah, if you do have a bad house, then you are.
Oh, yeah.
Yeah, just let it go.